9 a.m. Friday.
Hi guys, it's me Anders again. So welcome to my part 2 of my Road to AI series called, what do we call it? ServiceNow Adventures with Anders, part 2. There you go. So the goal of this series is to play around with technology within ServiceNow and see how we can get to the understanding of how AI works. So if you saw part 1, if you haven't, go and watch it. It's about search engines, and I'm making a search engine, and by doing that, investigating how it works, all the technology behind it, and those technology parts and bits I can reuse and make other cool things with. For example, this part, which will be machine learning, and it's unscripted, which is why I'm mumbling a little bit, and I don't care. So let's first start with the first video I had. There's music throughout the whole video, so there was a comment on YouTube about the volume was too loud and it didn't fit. Well, I actually like to have music in the background, and you know, it needs to be loud enough you to hear the music, because I want to hear the music. And just to be clear, it's not AI music, it's very personal. I made it myself, and you know, if you don't like it, then you know, turn on captions if that even, you know. In any case, so let me just get started. This is actually a session that I had made for Knowledge a few years back, and it was called Let's Make Machine Learning from Scratch with JavaScript. So it's not something I recommend people doing. I don't recommend you make anything from scratch unless, you know, it doesn't exist yet. So machine learning is absolutely something that is within ServiceNow already and works fine and does a lot of things. There's a difference between what I see as machine learning and AI. We'll get back to that, but the slide deck that I have here now is the same deck that I had at Knowledge. I'm just going to reuse it, but I'm going to try to show you some of the code this time. So last time I didn't have all the time in the world, so I had to just like show some code in the slide. I'll do that now too, but I can actually show some demos and some applications with this part. So yeah, if you like that kind of stupid stuff, then this is the video for you. So the goal in any case was to make something from scratch in order to understand how it works, which is how I feel any developer who wants to become an expert in any field, it doesn't help to just read about something. Of course, reading about how to perform specific functions from a book, or even have someone tell you how to do things, really helps. But it is my understanding that unless you actually type the code and understand the parts you're writing, you will never really truly master it. So that is the goal anyway. So the agenda is first talk a little bit about what machine learning is. There's a Storytime. It's a very cool story about the background of machine learning, and we'll show some code about how to make a simple machine learning model. We'll train it, and we'll use it in an application as well. It's gonna be fun. And then see if we can use this to make predictive intelligence. So if you're not aware, predictive intelligence in ServiceNow is when you have a ticket coming in, say a short description from an incident, and it predicts what assignment group this belongs to. So we'll use this model to predict an assignment group, and I'll show you how that works as well. Right, a little bit about me. So that way. This is me. I'm Anders. I'm from Norway, and I work in KPMG as an architect. I only work with ServiceNow, and I have some great customers in which I can truly help gain value from their ServiceNow platform, and that's why I love my job, really. I've been a developer before working with ServiceNow for about 25 years. It says 8 years of ServiceNow experience. This was a few years back, so I guess let's say between 9 and 10 years now. Next year will be one more year of experience. That's just how time works. It's great. And yeah, I like to hack systems or to really get into a system to learn how it works. And ServiceNow is no exception there. So I like to sort of try to make the functionality which is in ServiceNow in order for me to understand how ServiceNow platform works, and I can explain it to the customers because of my own experience and knowledge of the code. Right. So machine learning. So is machine learning artificial intelligence, or is artificial intelligence machine learning? So I guess there's not really a one answer to this, but in my understanding, artificial intelligence is when a system is smart enough to learn, right? While machine learning is like a subset where it's good enough to make a statistical prediction. I might be wrong, but that's just my understanding of it. So machine learning is not as advanced as artificial intelligence, but there are similarities. So there's always a data structure. There's data coming in. Based on the data, it sort of understands a pattern or learns something, right? So, but for machine learning and AI to exist, someone had to think through these things, and it goes back hundreds of years actually. And these guys weren't programmers, as you understand. By the year they lived. So let's look at this guy, Girolamo Cardano. So this guy was kind of had a gambling problem. So he was a genius mathematician. So what he tried to do was to create a math concept of how to see how I guess how much was his chances of winning. So I'll give an example. So he takes a die which has 6 sides, right? And when you throw a die, there's a statistical chance you'll hit the number 6. And how much is those chances? Well, he made that into just an easy math equation, which everybody understands now. You take one die side, which you want to hit, the number 6, and you divide it by 6, right? The possible sides, and there you have your sort of normalized number of your chances. So you can take that number times how many times you throw the die, and then sort of calculate how large your chances are of winning in that kind of game. He wasn't really a successful gambler, but he did know a little bit of math, right? So that was what is called the concept of expectation, probability theory. But that kicked off something. So then you have this guy over here, Jacob Bernoulli, who said, sure, but large numbers make more sense. So if you throw a die once and you hit number 6, does that mean you have 100% chance of hitting that number every time? Of course not. But if you throw that die 100 times, 1,000 times, 1,000,000 times, and then you divide your sort of trials with how with what you got of success or failures, then you have a much more correct statistics of that. So he said that was the large number, the law of large numbers, basically. Yeah. So that was published in a book after he died. Even there's a good explanation for what his theory was. His theory was that if all events are observed forever, everything in the world is governed by precise ratios and a constant law of change. So he had okay, let's say you have a box. There's a box, and you have pebbles in it. You have black and red pebbles in this box. If you take out a pebble and you register which color it was. So it was a red one. Okay, so you put number 1 on red on a piece of paper, and you put it back, you shake it, and you do it again. And you keep recording what you got, right? So you get, suddenly you got, after 100 tries, you picked 40 red and 60 black. You could safely assume that the ratio of red versus black pebbles in this box is 40-60. So, but the number gets more precise the more times you perform the test, right? So that was the law of large numbers. And This guy over here, his name is Pavel Nekrasov. He was a very religious type, and he tried to sort of take this law of large numbers as proof of God's existence. Why? He said, well, because this is an experiment that has a dependency. The dependency is that you have one box and you have a set number of pebbles in this box, and that is why there's a dependency there. So it's proof of God as it proved a dependency. Basically, you can't that everything has a dependency. He didn't like the idea of having this predetermined statistical fate, right? Because what Jacob Bernoulli said was that this goes for everything. So you could sort of predict everything based on statistical trials. He said, no, everything is because of religion, so you can't do that, but this actually proves the existence of God. And of course, nothing proves or disapproves anything, it's just math, right? And so there were expectations to probabilistic law arguing against strict determinism. So this is a battle of two ways of thinking at the time, right? So it proved free will or something like that. So he was he was a mathematician, but he was also very religious, and he was fighting for like his worldview. Then comes this guy, Andrei Markov, and he's sort of in this session the star, right? He was a rebel. First of all, he was an atheist, and he didn't like Pavel at all. Like, they were enemies. Like, one of them was from Moscow, the other one was from St. Petersburg. There was some rivalry there, and he was pretty mad at Pavel Nekrasov trying to switch this into a religious matter. So he sent letters to people telling them that Nekrasov was an idiot who didn't understand basic mathematical concepts. And he decided to make a proof of concept just to make a point, right? So as he said that the pebbles in a box statistical method had a dependency, proves free will, then Markov said, I'm going to prove you wrong by making an independent version of that trial, right? So let's have a look at that. So he created something which is now commonly known as a Markov chain. A Markov chain is two, let's say, boxes of pebbles. Let's call them A and B. So they're in a mathematical sense, they're called states. You have two states, and you have pebbles in both. So if you have a ratio in one and a ratio in the other one, you can perform the same experiment, but say that if you pick a black pebble in box A, that means you have to pick the next one from box B. And you have these rules that what makes sense to pick from the same box or the other one. But even though there's this independency, there's two boxes, but you have rules deciding when to switch back and forth, then you get the same results as the first one. So he sort of proved that Jacob Bernoulli's large numbers also had an independent sort of part of the rules, something, right? But what he didn't understand at the time was the implications of this model, because of course this is two states, but you can have a lot of states. So we're going to look at how this model goes into programming, and we can use that for everything. So the Markov chain is something we're going to program today, and we'll have a look. Alright, so what we want to do to begin with is to build the Markov chain function in the first place, and then we're going to load something into that chain, so that's training the model, and we're going to generate some text based on probable word sequencing. So what we're going to do is to load the contents of a book and see if we can look at the chaining of these words to sort of generate sentences which is statistically correct grammar, but it won't make any sense, obviously. And we will see if we can do something else with it as well, and in the end see if we can use it as a predictive intelligence code. So just to be conscious of time a little bit, I'll show you some code, but I won't show you all of the code. But if anyone at any time would like to have this code, I'll probably be able to link it in the description below or something, or you can just ask me about it and I'll share it happily. It's fine, you can have it. So let me just show you how the structure works in code. So you saw the back and forth in the diagram earlier. Well, now we're going to make like a structured string ordering, right? So first, let's say there's a few words in a sentence. We'll look at the first word, like word 1, and it will have an array of strings. So we'll actually look at pairs. So 2 pebbles, 2 words, 2 states. We'll look at 2 words at a time. So first word and second word. We'll take the first word and we'll make an array. This will be the property of an object, and it will have an array as the value. The value will be every single second word stemming from this one word. So if you have like my name is something something, we'll have the first word will be my, and word 2 will be name. But maybe sometime later in the book or text it will be my house, so it will be my, but word 3 will be house, right? So this will be the structure. And as you can see in this example, you have word 5, 5, 5, 5, or 6. So why it's repeated is because throughout the text you'll see the same order being repeated a lot. So like some word pairs are more often repeated. We'll just add them now. So there are ways to make the structure more compact, to add like a numbering or whatever, indexing. But for simplicity now, we'll just keep adding them. And when we are going to generate a sentence from this, we'll just take a random, like if the first word is my, then we'll take a random one from this one. And obviously there's a larger chance that these repeated words will hit, which means it's a statistical model. So statistically, word 5 is more likely to appear after word 1 than word 2. So that's how it works, right? We'll just keep doing that until we go through all of the words. So this is the code. Actually, let me go to the JavaScript itself. Let's see here. So there's a lot of code. I'm not going to go through everything. So they have some clean up scripts, like a function that cleans up from the text to remove special characters, just make it easier. But I'm keeping the punctuation and the commas, but I'm treating them as separate words actually. So in the structure you'll have commas and punctuation and exclamation marks, whatever you want to keep will be treated as just a sequence. So I'm trimming that away, I'm lowercasing it, just for simplicity. If you want to mess around with this, then you can do whatever you want. And I have a table in the global view. It's just because I was lazy when I made this, and loading whatever data. So I have a table with a book, for example. I'll show you. But this is the entire Markov chain function. So I'll go through it. So it takes an array of words. So you can pass it like a string, and you can decide that from this one I'll just make an array based on the space as a separation. Because I cleaned up everything, it will probably work. And it will make a chain of that one. So it takes an array and it makes the chain is an object, so it isn't really an array. So but an object has properties, and the properties are the unique names, and then we'll loop through them. So we'll take the first one and the second one. So remember, I told you we need the words in pairs. So first one, second word, then second word, third word, and so on and so on. So we're going to have the element and the next element. And then if we don't have it as a property in our Markov chain, we'll make it as an array. So which means, for example, and then my name is thing, the Markov chain element of my needs to be a new array. But if it does exist, so here it says if it doesn't exist, make an array. If it does exist, just say, all right, we'll push the next element and at the end there. And that's basically it. So it's quite simple. This is it. So you can imagine that predictive intelligence in ServiceNow, I don't know, it's not documented, but I could see it being as simple as this. In any case, this works fine, so you could have it as simple as this. So, okay, we have the chain and you need to build it. So what I'm doing is I'm basically loading a book, and I'm cleaning up the text a little bit up top here, just to remove special characters and make spaces. I make an array out of all of them, and I make a Markov chain that is returned from this function. And down here I'm gonna generate text. So without going through everything line for line, you can read it, you can pause it and read it if you want. Right, here's the text from book. It basically cleans up, makes the chain from the book and generates text. That's it, and generating text is here. And it basically looks at random words. So it takes a random object parameter, and then from that one looks at the following words and finds that one in the chain, takes a random one of the following word, takes a random of that one, and so on and so on. And that's it. So I'm gonna scroll down and we can have a look. So let's take, that's the last one I'm gonna look at. So what we're gonna do now, oh, actually, I'm gonna be a little bit, so like I told you, this isn't scripted, so I'm gonna be a little bit all over the place, but that doesn't matter. I wanna show you how it looks when you generate a Markov chain. So I'm gonna make a very simple one based on this little text. This is a Markov chain, and this is fun. And I'm gonna split it, as I told you, I need an array. So this one is gonna split and make an array based on space as a separator. So it's gonna make an array of this and feed it into this function, build Markov chain, and we're gonna output the JSON object later. So I'm gonna run script, and you can see here, this is, and you have two, in this area you have two is, and the reason is that you have this is, and this pair, and have this is here as well. So, which means that it found two instances of this word following that word, right? And then it takes a separate parameter based on that word is, and looks after what word pair comes after that one, A and fun, because this is A and this is fun, right? So that's how it looks. So now just want you to see that. So obviously this object will be huge when we take text from a book, and of course if you want to say, oh, that's too big, we can't work with it, go back to video 1, look at compression, works fine. You can just build a chain, compress it, save it in a table. It's very small, and you can just load it, unload, or use for whatever you want. It takes only seconds. When we load the book, it might take 10 seconds or 11 seconds when we build it, but that's, so for the examples now, it will take a few seconds if it's a small book, more seconds if it's a large book, blah blah blah. All right, let me just stop. Let me just comment out this part, and we're going to generate text from a book. So I told you a few minutes ago before I started rambling, we're basically taking the random words and randomizes the following in the chain. So it randomizes everything, but because of the parts that are more often occurring as word pairs, those are more likely to appear, and that's when we get some cool stuff. There's free books online, so I got the Frankenstein book, and I'm loading that one now. Oh, it just took half a second or something to build a chain. What does it say? It says, you can't see, I have to sort of drag this way, I guess. There we go. Merchantman now on being informed of London. However, the determined heart involuntarily pours itself to those shores which I've already engaged him, and my soul may receive your affectionate brother. Makes no sense, but it's sort of correct grammar, right? So let's just do another one. Conduct the voyages made for his country, but I have sense enough to dismay them increased. It makes no sense. But the use case for this is basically to create dummy data in ServiceNow. You can make dummy articles, you can sort of dummy tickets if you need, like, oh, I need 10,000 tickets to test out my new, I guess, statistical graphs or whatever. Then you can do this. You can just create a lot of these. But you can also generate names. So using the same logic, I'm gonna take this away. You can generate names. So this doesn't look quite as well, because I downloaded a list of names into a table as well. And instead of taking words, taking character pairs. So 2 characters from the name, and 2 characters from the name, 2 characters the next one, and so on. And treating them as word pairs and just putting them together. And this needs to build from a large list. So yeah, it sort of creates names. Tore Sami, Josh Ashu, Ice Issa, Mika Aika. This is names that doesn't exist. And by going to my function, let me see if I can show you. Generate names. So it takes a number of names. I load the data names and I lowercase them. The character group size. So how many characters in a group? And down here, yes, two groups. So this is a group and this is a group, right? So what I can do, I can change this to 4. I can run it again. And let's see. Yeah, it's actually 4 names. Rard, Art, or Rich, Icha. So these are 4 and 4 group size. I'm gonna change this to 8. You have larger ones. Franklin, Giovanni, Kendrick, Isabella. Yeah, so it's basically doesn't work anymore now because it's gonna try to group 8 and 8. Right. I'll take 3 and I'll try to change this to, I don't know, 5, whatever. Takes a bit longer because the list is long. Yeah, this didn't work out too well. It doesn't matter, you know, it's just for fun anyways. But if you want, you can use sort of the same functions to generate, you know, pairs of whatever and statistically get something that almost makes sense, but it really doesn't, right? So that's, you can use it for names. I guess this function isn't that. I had a function before that was much better. It's just to tweak these values a little bit, and it would be quite good at times. And of course, as with everything else, the quality of your input is important. So if my list of names is like 50 names, you won't get many variations. So remember the law of large numbers. The larger amount of data you have, the better quality you have in the end, right? So that goes for AI, goes for, yeah, this makes no sense. Let's swap this out with a different one. Let's go to a much more fun thing, which is this load and check. Load and check. My function load and check will do this. It will load my incidents, all of them, which have an assignment group. I'll build a frequency model. It basically does the same thing. So, but it does a slight difference. The Markov chain is the exact same function, but I'm using assignment groups as the parameters for the Markov chain, and you have words following them in the Markov chain as sort of values, right? And you have to make a little sort of tricky code where you say, you make a scoring system. So you say, okay, if these words, oh no, I got serious issues with payroll. You look at where in the chain does this occur. All of these words occur most, and you sort of rank them, and the one with the most points is going to that parameter. So you just sort of go back, right? I'm not going to show the function. Is a bit complicated to explain everything. We have to move on, but I'll show you. So, and it will just ignore if it doesn't find it in the chain. Oh no, I got serious. You know, it will probably ignore this and look for just issues with payroll. So if I run this one, it's going to say, yeah, here it says financial system support. Yeah, it makes sense, I guess. Let's try something which is HR related. Oh, by the way, I have to depend on ServiceNow's demo data, so you know I can't just write whatever I want now because there's really not that much data for me to play with. But I know that my higher right system fails or something. I don't know. Higher right is an HR system. See if it works. Yes, it did. HR system support. So this is predictive intelligence, and it works fairly well. If I ran a lot of tests, like I make a loop and just sort of randomized some words and put it in there, I'm pretty sure I would have around between 70 and 80% correct. I haven't tested this in like a customer instance yet, but it would be cool to see how well that would function, right? So let's see. That's actually all of it. Let's go back to some talking. Oops. Click the wrong button again. See, if you don't script something, it's much more fun, but at the same time, it's a bit unstructured. But who cares? You know, it's, what's the day? Tuesday? Yeah, it's Tuesday. Who cares? Who cares? So let's find my PowerPoint. Right. So it's behind here. You can see there was some years here that when these guys were making trouble. Today, what about this one then? So what about this? Now, obviously, the last year has been all about artificial intelligence. You know, when ChatGPT came out and became a big thing, everybody started to like try to incorporate AI. That is something very different than a statistical model like the Markov chain. Markov chain can be used for, actually has been used for big things. Do you know about how Google ranked websites? You know, the Google rank system for how you rank something to come further up in the scoring lists. That was actually a Markov chain. Not many people know that. Pretty sure that isn't the case anymore. That is a much bigger algorithm. But in the beginning, when the crawlers were looking through all the websites, it was actually scoring them based on how many websites were linking back and forth. So it sort of was was a Markov chain. And the more points it scored, a larger chain, then it came higher up. So in the beginning of the World Wide Web, people would say, oh, to get higher up, you have to link to my site, I'll link to your site, and you got like a bigger score, right? But now, of course, AI is much bigger. You have generative AI, you have predictive AI, you have a larger system, and it uses different data structures than a Markov chain. It doesn't use Markov chain at all. While, of course, you could combine them if you want. So the neural networks is what we're going to have a look at. So in the third video in this series, I'm going to show you how you can make a neural network from scratch as well. Of course, the point is to learn about neural networks. That's why we do it. Not saying you should. ServiceNow has perfect, already incorporated AI there. So, but if you really want to understand AI, we make it ourselves. So in my next video, I will show you how we can make a neural network and use applications in ServiceNow and, you know, have some fun with it, which is the point, right? Fun. So let's go back here. Thank you for watching, and I hope to see you in the next video, which is called ServiceNow Adventures with Anders Part 3 on our road to AI. See you later.